The next digital modulation technique we are discussing is a phase shift key. So it is binary phase shift key. We are discussing is binary phase shift key. What is phase shift key? So in phase shift keying modulation, digital modulation, phase of the carrier will shift according to the amplitude of your message signal. So phase of the carrier will shift according to the amplitude of message signal. Here only two symbols we are considering. BPSK, binary phase shift key. So you have only two symbols. Each symbol will represented by one bit, either a binary 1 or a binary 0. So as I told you, according to the amplitude of message signal changes, whether it is a binary 1 or it is a binary 0, according to the amplitude of the message signal, the carrier phase will shift. The carrier, it is a sinusoidal signal, as it is a digital modulation technique. Carrier is a continuous sinusoidal signal. So the carrier signals phase will change according to the amplitude of your message signal. That is binary phase shift key. So here, let's consider the unmodulated carrier signal over here. So the carrier signal is represented by root 2 ps cos omega 0t. Already you are aware of the sinusoidal signal representation. So normally we will represent as a VCT. So carrier signal is A or AC. AC that is a peak amplitude into cos omega 0t. Omega 0 is the angular frequency, or it is 2 pi f0, where f0 is the frequency of this carrier signal. Alright. So now what is power? So the power we can write it as, normally power PS is equal to A square divided by 2, or AC square divided by 2, that is the power. So now I can write AC as, it is 2 PS and it is root of 2, when it comes AC it is root 2 PS. So instead of AC I am just writing here root 2 PS. So it is same expression like what we discussed before. So the the carrier signal is represented as root 2 ps cos omega 0t. So now in the BPSK, as I told you, the transmitted signal, we will be representing, you have two symbol, binary 1 and a binary 0. If symbol 1 you are transmitting, you will transmit the carrier as set without any phase difference. If you are transmitting symbol 0, you will be transmitting it as root 2 ps cos omega 0t plus pi, a 180 degree phase shift. So cos omega 0t plus pi means even I can write it as minus root 2 ps cos omega 0t. So that is 180 means omega 0t plus pi means it is minus will come. The polarity will change. So that is the PSK signal, BPSK signal, transmitted signal we can write. So now let's see the example. So before that I'll just explain the generation of BPSK signal. So BPSK signal, here this message signal BT. You know BT will be, we are representing it is in bipolar form. So with you have two symbols. So for example, symbol 1 you will represent it as a plus, high voltage, and a symbol 0. You have two symbols. Symbol 0 you will represent by minus polarity. So you have a bipolar waveform you will be representing for your BT, and you have the product modulator. There the carrier wave, it is multiplying with the carrier wave. Carrier wave is nothing but AC cos 2 pi FC, or will represent as we wrote as F0. I mean omega 0, I'll write it as F0t. So your output will be BT multiplied by AC cos 2 pi F0t, or that is your final transmitted signal of BPSK, or even I can write it as BT into, this one I can write it as 2 root 2 ps cos omega 0 t. Root 2 ps cos omega 0. This is your transmitted signal st, or even I can represent it as VBPSK signal. This is the transmitted signal for BPSK. So now look at this waveform, how it is. So now think about the message signal data is 1, this is also 1, this is 0, this is again 1, 0, 1, 1, 0, 0, 0. Always this is the message signal. We will represent it as two polarity. So means 1 is represented by +1, 0 is represented by -1. Now carrier, so you have here showing us two carrier. It's nothing like that. If one is coming, this first carrier as such without any phase shift it will transmit. This is the carrier with the 180-degree phase shift. So a 0 comes, will transmit with a 180 degree, that is just opposite, into -1. We will transmit that. So that's about the BPSK signal, or you can see the same way you can explain that. That is just like multiply BT with a carrier signal. This BT is a bipolar waveform. I'll just show that how we can write with single carrier just with a product modulator, just with the multiplication of BT and carrier signal, how we will generate BPSK. So this is, see this example. Suppose your message bit BT is equal to 1 0 1 0. This is the message bit you want to transmit. Okay. So now I'm going to, first of all, I'm going to represent the message frequency, message signal. Each message bit of the duration TB, as I told you before. So now this is a TB, 2 TB, 3 TB and 4 TB. Okay, so now let's see, I'm representing my message signal in bipolar form because I'm just doing the product modulations, multiplication product only. I'm taking message and the carrier. So a 1 is represented by a positive voltage and a -0 is represented by a minus polarity. And again a 1 is represented by plus polarity, 0 is represented by a minus polarity. So 1, this is 0, this is 1, this is 0. So I am representing it by, say, two polarity, -1 and +1. Now let me draw the carrier waveform. So remember, when you draw the carrier should have integer number of cycles for each bit duration. Okay. So carrier should have an integer number of cycles for each bit duration. So this is the carrier signal. I'm going to draw the carrier signal now. This is say CT. I'm representing the carrier by CT. So first duration TB, 2 TB, 3 TB and 4 TB. So this is now TB, 2 TB, 3 TB and 4 TB. Alright. So now here I'm drawing two sine waves per 1 TB duration, 2 sine waves. So one integer number of cycles. Actually it is not sine, we represented it as a cosine wave. You should start from here. Anyway, now I'm just drawing it as a sine for your understanding. So this is, okay, now this one. Everywhere 2 cycles of sine wave. So when it comes 2 cycles of sine wave, now I'm going to draw my final BPSK signal ST, or that is equal to, even we can represent as VBPSK T. So again I'll just mark with the time duration TB, 2 TB and till, so it is TB, 2 TB, 3 TB and 4 TB. Okay, so just listen here. Now according to this polarity, either same polarity or 180 degree phase. When it's a 1, I will transmit the carrier as such. So this is 1 cycle, 2 cycle. When it is 0, that is a -1, I have to multiply with this. So this start from this point, right? So when I multiply with the -1, it just invert. So that means here it is started from 0 to high. I should start from negative. Again comes a +1. So I should start from same like positive because same thing will transmit. Again here 0. So minus. So it's inverted polarity. It should start from minus. So now see here when the polarity, when it is amplitude of your message signal changing from 1 to 0 or 0 to 1, the amplitude of message signal changing, there is a sudden shift in the phase of your BPSK signal, isn't it? So when it is changing from 1 to 0, so sudden phase shift is happening. It is not continuous phase. So this is called a PSK. Phase of the carrier signal will shift according to the amplitude of message signal. This is what is called a BPSK signal, and that's about the transmitter of BPSK.